Today we're going to talk about motion on a line, or you may know this as you may be more familiar with calling this position, velocity, and acceleration problems. In calculus, they often call this motion on a line. But there's three main functions you need to worry about when it comes to these, and that's the position function, the velocity function, and the acceleration function. And the position function you can look at as the original equation. Then the velocity function is the first derivative. The acceleration function is the second derivative. So if you go down this list, if you look over here to the right where it says derivative, if you want to move down this, in other words from position to velocity or from velocity to acceleration, you take the derivative. If you look over here at this side, if you want to go the other direction, you want to go up this list, in other words from acceleration to velocity or from velocity to position, then you need to take the antiderivative or take the integral. So if you just remember PVA, position, velocity, acceleration, that'll help you remember the order of things we're talking about. Now there's several things you need to know, especially when it comes to the AP test. First of all, you can estimate velocity by using the slope equation on the position function. So this is important because sometimes they don't give you an equation. Sometimes you may not be given a position, or sometimes they may give you the let's try that again. You may not always get a full equation. You may just get a series of points. They may be on a graph, or they may be in a chart or a table or something like that. And at that time they may ask you to estimate the velocity, and the way to do that then is to use the slope equation on the position function. Because if you remember, slope is the derivative, and when we use the slope equation we're finding the average over that period of time. So that's the best way to estimate velocity. In the same way, you can estimate acceleration by using the slope equation on the velocity function. So those two work the same way. Instead of taking the derivative, sometimes you may have to use the slope formula, just talking about y2 minus y1 over x2 minus x1, in order to estimate the slope, which would be the velocity or the acceleration at a certain point. Okay, next, an object changes direction when the velocity equals 0 or changes signs. Now the reason I worded it changes signs and didn't just say equals 0 is occasionally you may have a function that touches 0 but doesn't change signs. So if you look right here, for example, if we have a graph that does this, okay, this right here touches 0 but doesn't quite go under it, so there would be no change in direction. That just means something was moving forward, stopped, then continued moving forward. Whereas here we would have a change in direction because it actually changed from positive to negative. So this thing went forward, stopped, and then moved backward. But that's relating to the velocity equation. So an object changes direction when the velocity changes signs, which is also where it's going to hit 0. Now this is also where the position function has a maximum or a minimum. So if you have a graph of the position function, you change direction whenever you see a maximum or a minimum. Okay, and then to find the average velocity, you can either use the average value function on the velocity function. The average value is the one that looks like this, 1 over b minus a, integral from a to b of f of x dx. In this case it would be the velocity function you'd plug in for f of x. Or you can use the slope equation on the position function, which is also the way you can estimate velocity at a point. If you think about it, these are really the same thing. So this is what I basically said you should do is with the velocity equation is the average value formula. Well, if you take the antiderivative of the velocity function, in other words use the integral, you get the position function. It's usually x of t, actually not p of t. And then you could plug in the top equation, top number minus the bottom number, and put that all over b minus a, because I'm just taking this and putting it underneath. And if you notice, this is just the slope equation. So either one of those will work. Okay, just a couple more things. You can find the total distance traveled by using the integral of the absolute value of the velocity equation. And you can find the change in position or displacement by using just the regular integral of the velocity sign. So very quickly I'm going to try to explain the difference here. If you think about something going 2 steps forward and then 1 step back, that person has traveled a total of 3 steps, but they took 2 forward and 1 backwards. But in order to count the backwards one, that's why we use the absolute value. So that way, no matter what direction we're traveling, it gets counted. The negative doesn't cancel out the positive, because we want to know the total distance we went. Now, the second one, the change in position, well, if you think about the same scenario, someone takes 2 steps forward and 1 step back, they're only 1 step away from their starting point. So in that case, if we want to know just how far they are from the starting point, then we would use this, the change in position, which is the integral of the regular velocity equation. And finally, speed is increasing. Remember, speed is the absolute value of velocity. Speed is increasing when the velocity and acceleration have identical signs. They're either both positive or both negative. And speed is decreasing when the velocity and acceleration have opposite signs. One's positive and one's negative. These things are vital, and it's really important that you commit these facts to memory so that when you're asked questions about them, you know what you need to do.